Good morning, grade 12. This is Mrs. Pascale. Today's section is definite integrals, part 4. The objective of this section is to calculate different types of definite integrals. To calculate the following integrals, number 1, the integration of 5 over x dx over the boundaries 1e. We need to start by taking the constant outside the integral. So it's in the form 5 integral of 1 over x dx over 1e. Calculating the integration of 1 over x dx, we get ln x. So it's 5 ln x over the boundaries 1e. It gives 5 ln e minus ln 1. Since we need to replace x by e, then x by 1. Calculating this expression, it gives 5 into 1 minus 0, so the final answer is 5. And number 2, the integration over 0 pi over 2 of sine of x dx is equal minus cosine x over the interval 0 pi over 2. So replacing x by pi over 2, then x by 0, we get a minus into cosine pi over 2 minus cosine 0. You can write directly this expression on your calculator and you will get the final answer 1. And number 3, the integration of 8 over x cubed dx over minus 3, 4. First, we need to rearrange the writing of this function. So we need to write it in the power form or exponent form. So it's the integration over minus 3, 4 of 8x to the power negative 3 dx. Taking the constant outside the integral, we get 8 integral of minus 3, 4x to the power negative 3 dx. Then calculating this integration using the exponent or power rule, we get 8 x to the power negative 2 over negative 2 over the boundaries minus 3, 4. Simplifying 8 over minus 2, we get negative 4, then replacing x by 4 and x by negative 3, and calculating the expression obtained, we get 7 over 36. And number 4, the integration of 1 over radical x dx over 4, 9. First, we need to rearrange or rewrite the function in exponential form. So it's the integral over 4, 9 of x to the power negative half dx. Then applying the power rule, we get x to the power half over the interval 4, 9. Reducing this writing, the inverse or 1 over half gives 2. X to the power half gives square root of x over the interval 4 and 9. So replacing x by 9, then x by 4, we get 2 into radical 9 minus radical 4, which gives 2. And number 5, the integration over 2 and 3 of x over x squared minus 1 dx. As you see, this fraction cannot be reduced since we have in the denominator a difference of 2 terms. So we need, in this case, to use the substitution rule, which means to change the variable over this integration. And as we learned before, we need to take the supposition for the highest degree. So we need to take u equal x squared minus 1. The derivative over u gives 2x dx. Since we are changing the variable x, also the boundaries of the definite integral should be changed. So when x is equal to 3 as a upper boundary, replacing x in the expression of u, we get 3 square minus 1, which gives 8. So for the upper boundary, when we use the substitution method, the upper boundary over the variable u is 8. And for x is 2, again, if we replace x by 2 in the expression defining u, we get u equal to 3. So the lower boundary of the definite integral in terms of u is 3. Rewriting the integration, we notice that du should be defined as 2x dx. So we have a missing term 2 in the fraction, so we multiply and divide by 2 in order to replace directly by du. So the integral will be in the form of half integration of du, since we replace 2x dx by du, and x squared minus 1 by 1 over u, and the lower boundary by 3, the upper boundary by 8. Now we can calculate this definite integral using the rule of integration for the natural logarithm. So it gives half ln u over the boundaries 3, 8. So replacing u by 8, then u by 3, we get half into ln 8 minus ln 3. And number 6, the integration over 0, 1 of x into x squared plus 1 to the power of 3 dx. Again, it's an integral that cannot be rearranged or reduced in one of the rules taken. So we need to use the substitution method in order to change the form of this expression. So take u equal x squared plus 1, then the derivative over u is 2x dx. And since we are using the substitution method, we need to change the boundaries for x to transform it into u. So when x is 0, replacing 0 in the expression defining u, we get u equal to 1. Then when x is 1, we get u is equal to 2. We need to multiply and divide the integral by 2, since we have du is equal to x dx. Then replacing by each expression, 2x dx is replaced by du, x squared plus 1 is replaced by u, and the boundaries, the lower boundary of u over u is 1, the upper boundary over u is 2. Calculating this integration, we get u to the power 4 over 4 times half over the interval 1, 2. So it's 2 to the power 4 over 8 minus 1 to the power 4 over 8. So it's 15 over 8. The integration over minus 2, 1 for the expression or exponential function 4e to the power 2w plus 4w ew over ew dw. This fraction, since we have one term in the denominator, so we can divide each term in the numerator over the denominator and split the fraction. So in this question, we don't have to use the substitution rule, since we can rearrange the given function. So it's integral of minus 2, 1 of 4e to the power 2w over e to the power w plus 4w ew over ew, all multiplied by dw. Simplifying the first fraction, we get 4ew. Simplifying the second fraction, we get 4w. So we can calculate now the integral over minus 2, 1 for this expression. It gives 4e plus 4w squared over 2. All should be calculated over the boundaries minus 2, 1. Replacing w by 1, then w by negative 2, and calculating it or trying to simplifying it, we get 4e minus 4e to the power negative 2 minus 6. As application, please calculate the following integrals. Thank you.